Welcome to House of Past Paper Solutions. This is the 9709 May-June 2016 paper 4-1. First question reads, a lift moves upwards from rest and accelerates at 0.9 meters per second squared for 3 seconds. The lift then travels for 6 seconds at constant speed and finally slows down with a constant deceleration, stopping in a further 4 seconds. The first part says sketch a velocity time graph for the motion. So what you need is first you do your axis. For the first part, you draw your axis, and then for axis we want our y-axis to be the velocity, and then our x-axis we want it to be time in seconds. So it says that for the first 3 seconds, right? Since it's a sketch, it doesn't really matter where you mark on the graph. Okay, I'm gonna label that as my 3 seconds. And then it says the lift then travels for 6 seconds at a constant speed. Right. So right now what I want is, what is the velocity? We can use the Suvart equation since we know that the acceleration is constant. So we have v is equal to u plus at, and we know that u is equal to 0, therefore we have v is equal to at. Therefore, the acceleration that we have is 0.9, and the time we have is for 3 seconds. That will give us 2.7 meters per second, right? So then I'm going to mark that 2.7 on the graph right there. And then I know that it's going to be a straight line starting from 0, since the initial velocity was 0. It then says that the lift travels for 6 seconds at constant speed. So when we have constant speed, that means that the speed stays at 2.7 meters per second, right? So for 6 seconds, which is 6 plus 3 seconds, that will give us 9 seconds. Right? So yeah, at 9 seconds, we know that it's still traveling at constant speed, and then finally slows down with a constant deceleration, stopping in a further 4 seconds. So 9 seconds plus 4 seconds is going to be 13 seconds. So I'm just going to mark the 13 seconds here. And I know that the graph goes down like that. And there you go. That's your graph for part 1. Part 2, it says, find the distance traveled by the lift. So we know that the distance traveled by the lift will be given by the area under this graph, the graph that we just drew. So we know that distance is equal to area under a velocity time graph, a VT graph. So the area for this particular graph is going to be going to be given by you can see the shape is a perfect trapezium. So it's going to be half A plus B H. And then I'm going to say half multiplied by the A. In this case, it's going to be this length here. Like that. That's going to be the A. And then the B, which is 13 seconds, plus the B is going to be this length here, which is 6 seconds, right? And then multiply by the height. The height is going to be this height here, right? Which is 2.7. 2.7. So when you plug this into your calculator, you get the distance of 25.65 meters. And since this value exact, you have to leave it like that so that you get your full marks for that part. All right. Question 2. Question 2. Just gonna make space for question 2. All right. Question 2 says, a box of mass 25 kgs is pulled at a constant speed, a distance of 36 meters up a rough inclined plane at an angle 20 degrees to the horizontal. The box moves up a line of greater slope against a constant frictional force of 40 newtons. The force pulling the box is parallel to the line of greater slope. Find 1. The work done against the friction. So for this part here, we have work done. We know that work is given by the formula force multiplied by the distance traveled. In this case, since it's the force that we need is the frictional force, since this is the work done against friction, right? So we have our work is equal to the frictional force, which we have is 40, and then we want to multiply that by the distance traveled by the box, which is going to be the 36. And then with that, we'll get our answer as 1440 joules. That's our work. Then for the second part, it says the change in gravitational potential energy of the box. All right, so this is the situation that we have. We have the box traveling up a plane, an inclined plane. Right, and we know that this is 36. This whole distance here is 36 meters. So to get the height for the inclined plane, we know that the inclined plane is 20 degrees. To get the height, we know that it's going to be 36 sine 20 using the trig ratios. Right. So we want GPE, change in gravitational potential energy, which is going to be mass multiplied by the acceleration due to gravity and the change in height, which is this. So then we have the mass, which is 25, multiplied by the acceleration due to gravity, they multiply by the change in height, sine 20. And then that will give us 3078 joules. Right, that's our answer for the second part. And then the third part, part 3, the work done by the pulling force. All right, so the best way I would approach this part is just use an energy method. So we know that since energy is conserved in this system, it's a closed system, energy in is equal to energy out. Right, what is providing the energy? It is that driving force on the box. That is what is providing the energy. That is what we need, the work done by the pulling force, right? So that work done by the pulling force, I'm just going to call it D for driving, is going to be equal to, where is that energy going? As the box is being pulled up, it's gaining height here. It's gaining the height. So which means some of it is going into GPE. And then where is the other energy going? It's going into the work done against that frictional force of 40 newtons. So plus the work, frictional force. And we have our GPE, right? Our GPE is 3078 joules. Then we add that to our work done, which is 1440 joules. And then with that, we're going to get 4518 joules, right? Or you could just round it off to 3 significant figures in this case. Like that. And that's your answer to part 3. All right. Question 4. Question 4 says, the coplanar forces of magnitudes 50 newtons, 48 newtons, 14 newtons, p newtons act at a point in the directions shown in the diagram. The system is in equilibrium. That's the key point here. Given that tan alpha is equal to 7/24, find the values of p and theta. All right, so for this particular question here, since we have a value for tan alpha, I'm sure you know from the trig ratios, you know that we have the mnemonic SOHCAHTOA, right? And we know that tan we know that if tan alpha is equal to 7/24, right? This means that this is the opposite over the adjacent, right? So we can make a triangle because of that. We can draw a triangle, right? Then we have our triangle like that. Okay, and then it's gonna have our angle here. of alpha, and our opposite is going to be 7, and this is going to be 24. Then we can use the Pythagoras theorem to find this hypotenuse here, which is going to be 7 squared plus 24 squared root that. We're gonna get that is 25. Right. So we can write the 25 on the triangle. Right. That's how I come up with the other trig ratio. With that means our sine alpha is going to be equal to from our SOHCAHTOA opposite 7 over the hypotenuse is 25, and our cos alpha is going to be equal to the adjacent over our hypotenuse 25. You see, we're going to need these ratios, these trig ratios, right? Then the second part, how I would approach this question here. So I'm going to place that there. The second part, how I would approach this question, right? We know that the system is in equilibrium. That means that the forces at that point right there, this point right there, they are all balancing. It's equal to 0. So that means the force upwards and the force downwards, they are all equal, right? And then that also means the force to the left and the force to the right, they are also equal. That is what it means, right? So I'm going to use that fact to make two equations, and then I'm going to solve simultaneously to get the values of p and theta. All right. So let me show you how I do that. So I'm going to have the summation in the x direction is equal to 0. Therefore, right, I'm going to resolve for the 48 Newton force, this one right here. This force here is going to be equal to 48 cos alpha, and then this is going to be the positive direction, this is going to be the negative direction, up is going to be positive and down is going to be negative. Remember, force is a vector quantity, which means it has magnitude and direction. Then I'm going to subtract the force is going to the left. In this case, this side, I want to subtract the p. All right, how do I determine the angle for the 40 Newton force? Let me zoom in and show you. So if I zoom in right here, like this, if I draw this line, this paper line here, look, we have this angle here is alpha, right? And we know that this, since it's a straight line, we know that this angle here, this one only, this angle there is now 90, right? Since that's 90, but we also know that this angle here, this whole angle here, is also equal to 90, right? Therefore, we know that this part here, right? This is 90, but I want to show you. If I rub this out, this part here, right? Because of the 90 that I just rubbed out, right? This part here becomes 90 minus this alpha, right? So that I get this angle. And then now to get this angle here, this whole thing is now equal to 90. Therefore, to get this part, this tiny part right here, this angle, this tiny part, I'm going to say 90 minus alpha, which is this part, right there. I'm going to subtract that in order to get this tiny piece here. All right. And then so that would give me 90 minus 90 plus alpha. This cancels out. Therefore, that means this angle here is also equal to alpha. Why am I doing that? Because I want to resolve in this direction. Right? When I do that, this is going to be 14 sine alpha going in that direction. And then this part, this direction, you can see it's the adjacent of that triangle. Let me just rub out some of this. You can see that this line here is the adjacent of this newly formed triangle. right? Then this is going to be, therefore, this part here is going to be 14. When I resolve it, it's going to be 14 cos alpha, right? Like that. So now I've resolved my angles. So it's going to be, for this particular question here, minus, remember, I want this part, that direction, the 14 newtons resolved to the left, and that's going to be minus 14 sine alpha, right? And then I'm going to subtract, right? Then I'm going to resolve the P Newton force. I'm going to resolve in that direction, which is going to be equal to P cos theta, right? Then I'm going to subtract that. P cos theta is equal to 0, right? That's my first equation, right? So I can make a P sec cos theta subject to the formula. Then you have P cos theta is equal to this, is equal to that, like that. It's 14 sine alpha is a 14 sine alpha, like that. That's my equation 1. And then I'm going to do the same thing in the y direction. I know that it is equal to 0, right? Since it's in equilibrium, the forces in the upward direction and the downward direction cancel out. So in the upward direction, I have 50 as a first force, 50. Then I'm going to resolve the P Newton force in the y direction going down. It's going to be negative P sine theta. And then the 14 Newton force in the going down in the direction, in the downward direction, will be 14 cos alpha. And then minus the 48 Newton force is going to be 48 sine alpha. And I know that that is going to be equal to 0. Then I'm going to make P sine theta subject to the formula by taking it to the other side. Is equal to 50 minus 14 cos alpha minus 48 sine alpha. Remember, the sine alpha and the cos alpha ratios, we already got these right here. We already got those right there. Right? There they are. We know that sine alpha is 7 over 25 and cos alpha is 24 over 25. Right? So this is my second equation. With that, I'm gonna move down. Right, let's solve them simultaneously. Right, look, if you divide 2 over 1 like that, you're gonna have you can actually you're gonna have P sine theta. You're gonna have this whole part here. You're gonna have that, right? Then it's going to be all over 1. Like that, right? That is what I'm gonna have. It's equal to that, right? So this, the p's cancel out. This turns into 10 theta. Therefore, now I have 10 theta is equal to. Then I'm gonna plug in this here. Cos alpha is 24 over 25. Sine alpha is 7 over 25. Same here, 7 over 25 and 24 over 25. Right? Therefore, tan theta is going to be equal to when you solve that, when you plug that in the calculator, you're gonna get 23.12. When you plug this into the calculator, you're gonna get 42.12. Right. So essentially, you're gonna get P sine theta is equal to 23.12, and P cos theta is 42.16. This is what you get. I'm just going to place that right there. Okay. Then you can find your theta by finding the inverse tan of that value, which is going to be simplified further in your calculator, is going to be 17/31. This whole thing here is going to be 17/31. Right. When you do that, you get your theta is 28.7 to 1 degree, 1 dp, like that. And then for the value of E, remember I have these values here, right? What I could do is I could use trig ratios, the SOHCAHTOA. So then I would say the sine theta is equal to 23/12 over P, and cos theta is equal to 42.16 over P, right? Then if I draw the triangle, right? Remember, this is opposite over hypotenuse, and this is adjacent over hypotenuse. So we know that the hypotenuse is P, and the adjacent is 42.16, like that. And the opposite, right, of the theta right there is 23.12. Now it's clear how to find P, Pythagoras theorem. P squared is equals to 23.12 squared. That's how you get the exact value for P here, squared. Then you could square both sides. By squaring that, then your P is going to be equal to, when you plug that in the calculator, it's going to be equal to 48.1 newtons to 3 significant figures. Like that. Therefore, your final answers, you have P is equal to 48.1 newtons, and you have theta is 28.7 degrees, like that. And that's your working for question 4. All right. Then now question 5. It says, two particles of mass is 5 kgs and 10 kgs are connected by a light inextensible string that passes over a fixed pulley. The 5 kg particle is on a rough inclined slope, which is at an angle alpha to the horizontal, where tan alpha is equal to 3/4. You see, whenever we get this, that means we have all trig ratios set. So we have sine alpha, we have cos alpha, right? The 10 kg particle hangs below the pulley, which is this one. C diagram. The coefficient of friction between the slope and the 5 kg particle is half. So we know that mu is equal to 0.5, right? Then the particles are released from rest. Find the acceleration of the particles and the tension in the string. All right, so the way I would approach this question is, again, I'm gonna form two equations. Let me show you. So if you come here, we have, this is the situation that we have. The 10 kg is the 10g weight, is a weight of 10g, where g is equal to, it's the acceleration due to gravity, right? I'm sure you know this. Right? And then it is the tension that is acting up, like that is opposing that force. And then same here, the 5 kg, when the system is released, the 10 kg, since it's heavier, it's going to start moving down. So our system is always going to be moving down in that direction, not the other way around. That's one thing that you have to note. You just note the masses The heavier one is the one that's going to pull the other one. All right. So here we have our tension again, and then we have the component of the weight acting down the slope, right, opposing that force together with the friction. Remember, friction also opposes the force, right? So this is also the frictional force, right? And look, if I draw a line going down, right, and we know that weight is always acting vertically down. So this is 5G. I want to find that component. If I draw that, you see, this is the component that I need. That right there. That's the component that I need. That's the component that I need. So to find this angle here, look, this is 90, right? So therefore, this becomes 90 minus alpha. And this whole angle here is 90. So therefore, this is alpha. When you add that up, we get 90, right? So which means this part here is going to be 5G sine alpha. That is the component going down, acting down slope. Sine alpha, right? And then we know that we usually have the reaction that acts perpendicular to the slope, right? And we know that the component of the weight acting in parallel to the reaction is the adjacent side of this triangle, which is 5G. 5G is the weight, remember? 5G cos alpha, like that. Okay, so the diagram is a bit messy, but I hope you get it. Let me just rub this out. This is the weight, which is 5G. Right, okay. So what I'm gonna do is I'm gonna form two simultaneous equations using Newton's second law. Right. So from Newton's second law, right, this is what I'm gonna have. I'm gonna have the 10 acting down, which is the Newton's second law. Remember, it's F is equal to ma, and we want that acceleration, right? The force is usually the total force, considering the fact that force is a vector quantity. So which means opposing forces we have opposite signs. In this case, I'm gonna take the 10G, this 10G here as positive, and I'm gonna take this T as negative since it's opposing the motion. Right. So for the first equation, for that 10 kg mass, right, it's gonna be 10G minus T is equal to the mass, which is 10 kg, and the acceleration. That's going to be the equation 1. Then same applies for the second particle, right? The second particle, this is what I have. I have the particle itself, and we have a frictional force acting in that direction. Then we have our frictional force, which is given by mu r, right? And then we have the component of the weight acting downslope, which is 5G sine alpha. And then upwards, we have T. Since T is greater, because it's moving up, I'm gonna put this as the positive and these guys as the negative. Yeah, then, right. So it's gonna be T like that. T minus 5G sine alpha minus 2.5G cos alpha. We take it the 2.5G. Recall if the friction is equal to mu r and mu is equal to 0.5, and our r right there, this is our r right there, this, which is 5G cos alpha And then when you multiply those, you just get 2.5 g cos alpha. And that is what I put down there. Cos alpha is all equal to 5a. That is equation 2. Right. So using the data that we got in the question, this data, the fact that tan alpha is equal to 3/4. Right, we could come again and draw a triangle, a small triangle. In this case, and then we have for alpha. The 3 is the opposite, the 4 is the adjacent, and if you do Pythagoras theorem, you know that the hypotenuse is 5. Therefore, that means sine alpha is equal to 3/5, and cos alpha is equal to 4/5. Right. So I'm gonna add the equations, equation 1 and 2. When I add those equations, equation 1 and 2, the t's are gonna cancel out, and then I'm gonna be left with 10g minus 5 minus 5g 5g sine alpha minus 2.5 g cos alpha is equal to 15a. Right. Then I'm gonna plug in the alpha and cos using these two. Then I'm going to take out the g. Then this is 10 minus 5 over 3/5 for the sine alpha minus 2.5 multiplied by 4/5 for the cos alpha. There you go, like that. It's all equal to 15a. Right, and then when I simplify that, this g is equal to 10. So I have 10. When I simplify that, I have 5, which is equal to 15a. Right, and that is equal to, so that means our a is equal to 50/15, which simplifies to 10/3 meters per second squared. Or you could write it as 3.33 recurring meters per second squared. Both answers work. Cambridge will accept both of them. Right. Now to find t, since it's a simultaneous equation, I'm going to use equation 1. I'm going to use equation 1. So t is equal to 10. There's equation 1. There. Right there. Right, let me copy it so that you're not lost. Right, there you go. That's equation 1. So I'm gonna rearrange that. Take t to the other side. Take 10a to the other side. 10g minus 10a is equal to t. So this is 10 multiplied by 10 minus 10/10/3 multiplied by 10/3, which is equal to t. When we put that in the calculator, we get t is equal to 200/3 newtons, which is equal to 66.7 newtons. And that's it with our answers. So our answers, t is equal to 66.7 newtons, and our acceleration is going to say 3.33 recurring meters per second squared, like that. And that's it for question 5. Now question 6. Right, I'm gonna clear the space here. Okay. Question 6, it says, a particle moves in a straight line. It starts at a point O on the line and a time t seconds. After leaving O, it has a velocity v meters per second squared, where v is equal to that. Right? Yeah. There's also one thing that I want you to note. We use the Shewhart equations, right? The Shewhart equations. If you know what those are, the v is equal to u plus AT is equals to UT plus half AT squared the equations. V squared is equals to U squared plus 2AS, right? And all those are the equations, right? We only use this exclusively when the acceleration is constant, right? When the acceleration is not constant, right? When acceleration is not constant, we use calculus, right? Please note this. We go straight to calculus. There's no debate about that. And this equation, as you can see, since the velocity is varying, is given as an equation. The very moment you see this, you should know that you're now doing calculus. All right. Okay. Let's get going with question. So part one, it says, find the set of values for which the acceleration of the particle is negative. All right. So it's saying acceleration is less than 0. Those are the values that we need. When is the acceleration less than 0? When is it negative? So the first thing that we need to find is the acceleration itself, right? Since we have just the equation for velocity. It says velocity is equal to 60 squared minus 30t plus 24, right? And we know that dv dt, the rate of change of velocity, is equal to the acceleration. So we can just differentiate that. When we differentiate that, we get 12t, right? We multiply that and then subtract the power, 12t minus 30, right? And we want that to be less than 0, right? So we solve for t, 30 over 12. That will happen when t right. So when t is less than 2.5 seconds, the acceleration is going to be negative. And you can verify that by plugging in any value of t that is less than 2.5 seconds into this equation right here. And you will see that it will always be less than 0. Always be less than 0. All right, this is part one. Part two. Find the distance between the two positions at which p is at instantaneous rest. So we want to find the values of t when v is 0. What is t when v is equal to 0? We have the equation for velocity. Minus 30t plus 24 is equal to 0. Right, the first thing that I'm going to do, solve this equation. Divide by 6, since we can factor out the 6. Then t squared minus 5t. 30 divided by 6 is going to be 5. And then plus 24 divided by 6 is going to be 4 is equal to 0. Then you can factor that out. Two numbers that multiply to give you 4 and 8 to give you negative 5. It's going to be negative 4, right? And negative 1. If you multiply negative 4 and negative 1, you're going to get 4. If you add them, you're going to get negative 5. Is equal to 0. Therefore, you have your t is equal to 1 and your t is equal to 4, right? And those are your two positions, the two times when p is at instantaneous rest. All right. So now that we have the two times at which p is at instantaneous rest, now we need to find the distance, right? We know that the rate of change of distance, the ds dt, is equal to v. Therefore, we just have to differentiate. We just have to integrate the velocity equation so that we get v. So it's going to be, look, ds dt is equal to 60 squared minus 30t plus 24. Then I multiply dt to the other side. And I'm going to have ds is equal to 60 squared minus 30t plus 24 divided by dt. See, then I integrate those, and I have my limits. These are going to be the limits, right? So I have s is equal to, when I integrate that, I'm going to get 2 squared minus 15t, 15 squared, 15t squared plus 24t, right, plus c, which really doesn't matter in this case because I'm going to plug in the limits, which is 4 and 1. So I want to find that distance right there. Remember, this is not displacement, this is distance. So you need to find the distance, the displacement after at 4 seconds, at t is equal to 4 seconds, right? Then you add it to the displacement at t is equal to 1 second. I don't know if that makes sense. Remember, displacement is a straight line distance, right? And the distance and it's a vector, right? But distance is not a vector, just as magnitude only, right? So I'm gonna plug in that it's when t is equal to 4. So it's 2, 43 minus 15, 4 to the 2 plus 24, 4, right? And then I'm gonna get that is negative 16. But I just want the magnitude of that. Same thing. I'm gonna do that with the 1. Plug in as well. 2, 1, 3 minus 15, 1 plus 24, 1, which is equal to 11. I just want the magnitude. So the magnitude of that, right, at t is equals to 4, is at t is equals to 1. The magnitude of that is just 11, and the magnitude of that is just 16. Therefore, I find the distance now, which is equal to 16 plus 11. And then I get that as 27 meters. All right, I hope that's clear. So why am I not subtracting the limits as we do in normal integration? Because if we do that, look, we will have negative 16, then we're going to subtract minus 11, right? And then this is going to give us the negative 27, right? And well, we could get that. What we really need, what we really want is the magnitude of that, which is just 27, right? So I thought it might be confusing to you because sometimes, you know what, you might get the 11 as a positive, as a negative, and then it's going to get confusing, right? So the best way to do it is just to get the magnitude of 4 and the magnitude when t is 1 and the magnitude of s when t is 4, right? Then the last question, for number 6, it's going to be find the two positive values of t at which p passes through O. All right. I know that t passes through O, right? So if the particle here, it starts here at O, then it moves along as the particle. The only time it passes through O, right? Remember, it is this any distance will be s. Any displacement from O will be s. So I know that if the particle p right here is to pass through O, right? That means s would have to be equal to 0, right? And I still have that equation for s. It was s equal to 3 plus 15t squared plus 24t. Remember in the exam, you actually have the equation. It's not like you're rubbing out the working. I just need space. That's why I'm rubbing it out. So I want to find the value of t when s is equal to 0. All right. So I want t, what is t equal to when s is equal to 0? So that's what I'm going to do. Right, is equal to 0. Then I'm going to factor out the t in this case. Since the equation doesn't have a constant term, then I'm going to have 2t squared plus 15t plus 24. Right, is equal to 0. Now I already have one value, which is t is equal to 0. And this is true because remember this particle started at p. So at p, it started at point O, right? So when time is equal to 0, it was at the origin. There was no displacement. Displacement was equal to 0. Then for this equation here, that is remaining, I'm going to solve it using the quadratic formula. So it's going to be negative. This is supposed to be negative, right? Negative, right? So it's going to be negative 15 plus or minus root negative 15 squared minus 15t plus minus 4 multiplied by 2, which is the a, and then c, 4ac, remember, which is the 24. Then you divide that by 2a. This is from the quadratic formula, which says minus b plus or minus b squared minus 4ac over 2a. That is what I used here. Okay. Right. When I do that, this is equal to t. When I do that, I get the two values for t. It's to three significant figures as t is equal to 5.19 and t is equal to 2.31 seconds. Right, and those are my values, my answers to the two positive values. Remember, it says positive values of t. Those will be my solutions for that question. Easy like that. Now, question 7. I'm just gonna make space again. Right, question 7. A particle of mass 30 kg is on a plane inclined at an angle of 20 degrees to the horizontal. Starting from rest, the particle is pulled up the plane by a force of magnitude 200 newtons acting parallel to the line of greatest law. Given that the plane is smooth, find A, the acceleration of the particle, the change in kinetic energy after the particle is moved 12 meters up. Right, so this is the scenario that we have. Let me show you. So let me draw a triangle so that you see what we have. So yeah, well, something like that. There you go. So we have a particle that has a constant mass, a constant force, pulling force of 200 newtons. It says it's 218 parallel to the plane, right? To the line of greatest law, right? And then we know that this is 20 degrees. And we know that there's going to be the component of the weight acting down plane, right? From the previous question that I did, now you know that this component is going to be equal to mg sine 20. And so I'm just going to write it. AM is 30. Then we have G sine 20. That's the component of the weight acting down slope, right? So for part A, it's saying calculate the acceleration of the particle. I'm going to use Newton 2 from Newton's second law, which is the force is equal to ma. right? I want to find the acceleration using that. So I know that since it's being pulled up, that means I'm going to take that as the positive direction. So 200. Then this is the opposing force in the negative direction, is the negative force. 30 g sine 20. And then the mass is 30. Then we have the acceleration. The mass is 30. Then we have the acceleration right there. And when we solve for the acceleration, it's going to be equal to 200 minus 30 10 sine 20 all over the 30. That's going to give me 3.25 meters per second squared. Like that. Right, that's the part A. Then part B, it says the change in kinetic energy after the particle is moved 12 meters off the plane. So in this case, look, the pulling force, right, the 200 newtons is constant, and the mass is constant. Therefore, these forces are going to be constant. That means the acceleration is going to be constant. And remember what I just said from earlier. Whenever the acceleration is constant, I'm going to use the Stoffer equations, right? So B, part 1B, right? I'm going to use the Stoffer equation. So what I'm going to do is, remember, kinetic energy is equal to half mv squared, right? So I want to find that change in v, right? And I'm going to use the Stoffer equation. V is equals to u plus 18. I mean, sorry, which is v squared is equals to u squared. Plus, you got to use the Stoffer equation, which you have the most variables for, right? So we know that u squared, the initial velocity, it starts off at rest, so it's 0. I know the acceleration, which is 3.25. I know the distance it travels up the plane, which is 12 meters. So therefore, v squared is equal to 2 multiplied by 3.25 multiplied by 12. Right, like that. And that is going to be equal to v squared is equal to 78. Therefore, change in kinetic energy is equal to half multiplied by the mass, which is 30 kgs, multiplied by the v squared, which is 78. When I multiply that, I'm just gonna, when I put that in a calculator, I'm gonna get 1170 joules. Like that, exact. Like that, and that's my answer for part B. Right, and then part 2. It is given instead that the plane is rough and the coefficient of friction between the particle and the plane is 0.12. Alright, so I'm gonna use the same diagram. I want to clear up the space so that I can use the same diagram. Right. So now we have coefficient, we have the friction acting on the diagram, on the particle, right? So we're gonna add the component of friction on the particle, right? So friction is opposing motion. Remember, the particle is still moving up; it's opposing motion, and we know that the frictional force, if this is F, is equal to mu r, and we know that the component that is, we have, this is the reaction, right? We know that mu r, where r is the reaction, and we know that the component of weight that acts parallel to the reaction is equal to 30g plus 20. Remember, I already showed you how to derive this in the previous question, right? Like that. Then we have mu. We know that the mu is given coefficient of friction 0.12, right? So I'm gonna use again Newton 2. Newton 2 is our friend in most of these questions, really. From Newton 2, which is Newton's second law of motion, which is Fa, right? So usually the resultant force is equal to Ma, right? Okay. So again, I'm going to take the 200 positive and the opposing motions as negative. The first opposing motion is the component of weight acting down parallel to the plane, which is 30 g sine 20. And then minus the friction, that is now opposing motion, friction force, which is mu r, remember. The mu is 0.12. Multiply that by the 30 g. The r, remember r is equal to r is going to be equal to 30 g cos 20, right? And then so it's gonna be cos 30 g cos 20 is equal to the mass, which is 30 a, okay, right? And then when I plug that in the calculator, I'm gonna get 2.1188 meters per second squared. Then to three significant figures, acceleration is going to be equal to 2.12 meters per second squared, like that. All right. And then B, part 2B, it says the direction of the force of magnitude 200 is changed, and the force now acts at an angle of 10 degrees above the line of greatest slope. Find the acceleration of the particle. All right. So this was part 2A, right? Now I want part 2B. All right. So I'm gonna go back to the diagram. Look. So they're saying this magnitude here, it's now acting at 10 degree at a 10-degree angle. So something like that. Like that. This is now the 200 Newton force, acting at 10 degrees. So we just resolve again, acting at 10 degrees like that. So this means this now becomes 200 cos 10, right? And then we have this force right there. Let me just label this as 200 here. Then we have the component, right? The vertical component of the 200 Newton force is going to be equal to 200 200 sine 10, like that, right? How does it affect our equation? It affects our, remember I'm saying going up is positive and going down is negative. In this case, it also now affects our reaction force, because look, we now have two forces acting perpendicular to the plane, right? Look, we have the r going in that direction, and we have the 200 sine 10 in that direction, and then in this direction we just have 30 g cos 20. So we're going to modify our equation like that. We're going to employ Newton's second law again, right? I'm going to employ Newton's second law, right? So the force is acting up. I'm going to have my 200. In this case now, if the Fr nu, right, is going to be equal to, we're going to have, this is how you do it. Use Newton's second law to find R, first. So you say R plus the 200 sine 10, right, is equal to the 30 g cos 20, and R is going to be equal to 30 g cos 20 minus 200 sine, this pen is too thick, huh? All right, like that. That's going to be the R, right? Now with that we can calculate our acceleration. So it's going to be the force upwards, the upward force, this one, 200 is going to be 200 cos 10, right, minus force acting down, which is still this one, right, 30 g sine 20. Then I'm going to subtract the frictional force, this one, this frictional force. But now it's now ff nu, right, ff naught, right, which is going to be, we're going to have this r here. Ff naught is going to be equal to mu r naught, right? So I'm going to multiply this whole thing here, this whole thing by the mu. It's going to look something like that. 0.12 divided by 30g cos 20 minus 200 sine 10, like that. And all of that is equal to 30a. Where is this formula coming from? It's coming from Newton's second law, which says the summation of the forces, or the resultant force, the resultant force is going to be equal to mass times acceleration, right? So I'm just going to find the resultant force, right? After for the resultant force of all the forces acting on the particle, right? When I add them up, considering their directions, since force is a vector, right, I'm gonna get an acceleration, right? If they are not balanced. If they are balanced, then there will be no acceleration. But this case, it already says find the acceleration, so we know they are not balanced. Okay. Right. So when I plug that in the calculator, I'm gonna get my acceleration is 2.156, which becomes 2.16 meters per second squared. And that's it. That's it for the paper. Please guys, thank you for watching. If you thoroughly enjoyed this paper, please consider subscribing. That's going to help me to continue to make content like this. Thank you very much. Peace.